Hey everybody, it's Miss Berry. In this video, we're going to go over section 3.3, which covers quadratic functions. So first, we'll start by just talking about what is a quadratic function. So a quadratic function has the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. So quadratic functions are second degree polynomials, which means that their highest exponent is 2. The way that I've written this quadratic function here is called standard form. And standard form just refers to when we have everything multiplied out and we have all of our like terms combined. Graphically, quadratic functions appear as parabolas. And these parabolas can look one of two ways. So they will either look like this, like a U shape, or they will look like an upside down U. It's really easy to tell what your parabola is going to look like if you look at your function. So whether or not your parabola is what we call concave up or concave down, so concave up like a cup, concave down like a frown, whether or not your parabola is concave up or concave down depends on the value of a. All right, so that a from our quadratic function up there in standard form determines whether our parabola will be concave up or concave down. So if a is positive, if a is greater than 0, your parabola will be concave up. And if a is negative, or if a is less than 0, then your parabola will be concave down. So that's one way you can check if you're graphing a parabola to make sure that you have done everything correctly, is to just check and see, does this parabola look the way that I anticipated it would look? So if a is positive, is the parabola concave up? If a is negative, is the parabola concave down? And then the last thing I wanted to mention is that sometimes you will hear quadratic functions referred to as second degree functions. So if you see that wording, just know that that's referring to a quadratic function. So remember, when we're talking about polynomials, the degree of a polynomial is its highest exponent. So here the highest exponent is 2. That's why it's called a second degree function or a second degree polynomial. All right, and parabolas have a special point on them. If the graph is concave up, it's down here at the very bottom. And if the graph is concave down, the special point's up there at the top. This point is so special that we give it a name. We call it the vertex. So you can see that if my graph is concave up, then the vertex is going to be the minimum. So it's the minimum point. And if my graph is concave down, the vertex will be the maximum point. So anytime you're asked to find the max or the min, so the maximum or the minimum, and you're dealing with a quadratic function, just know that that's referring to the vertex. So anytime you're asked to find the maximum or the minimum and you're dealing with a quadratic function, just know that that point is the vertex. All right, so let's talk about how to identify the vertex. the easiest way to identify the vertex is when the quadratic function is in what we call vertex form. So this is what vertex form looks like. This is just another way that you can write quadratic functions. So it's f of x equals a times x minus h squared plus k. And again, this is just another way that you can write quadratic functions. If you're starting out with a function that's in standard form, like we saw on the last page, you can force that function into vertex form by completing the square. So if you would like to put your quadratic functions into standard form, or excuse me, into vertex form, and you're starting with something that's in standard form, you can always complete the square and do it that way. This is called vertex form because it's very easy to identify the vertex when you're in vertex form. Right, so it's called vertex form because it makes it really easy to identify the vertex. Right, and the vertex is a point on the graph, which means that it's going to have two parts. It's going to have an x-coordinate and a y-coordinate. And the vertex of a quadratic function that's in vertex form is h, comma, k. All right, so the h comes from right here. So here's the h, and here's the k. All right, so this is something that you will want to know for the next test, so very important information here. I want to go over just a couple of examples where we're given a function in vertex form, and I want to show you how you would identify the vertex. So let's do that next. All right, so we're going to call this just some extra examples. And the directions say, or are going to say, find the vertex. All right, we'll do part A. F of x equals 2 times x minus 3 squared plus 7. All right, so f of x equals 2 times x minus 3 squared plus 7. We can easily identify that this is in vertex form. Vertex form looks very different from standard form. So it's easy for me to see just by looking at this that it's in vertex form. You can see that I've written vertex form up underneath here, so I can just easily match up what my values are. So I see here that the value of A is 2. So since A is positive, that tells me that my graph is going to be concave up. They didn't ask us to identify that, but that's just something nice to know, especially if you have to graph the parabola. It's nice to have an idea of what your parabola should look like. All right, but here we're finding the vertex. We know the formula for the vertex is HK, so it's the ordered pair HK. All right, so I can see here that, notice how this minus is matching up with this minus. Then H matches up with just the 3. So H is not negative 3 because this minus matches with this minus, which means that this H just matches with the 3. All right, so my vertex is going to be, the x coordinate is going to be 3. Then I can see that my y coordinate, k, is positive 7. So that's my vertex. So let me show you what happens when we end up having a plus inside of the parentheses instead of a minus. All right, so we're going to make up another example. We're going to say f of x equals negative, parentheses, x plus 2 squared minus 5. All right, so I'm going to go ahead and write vertex form up underneath this. Now, first of all, I just wanted to note that I noticed that my value for A is -1, which tells me that my graph is going to be concave down since A is negative. I can tell that I'm in vertex form, so I know that my vertex is going to be the ordered pair HK. All right, so I see an issue here. My formula has a minus in it, but my problem has a plus. So that's not too big an issue. I can change that plus to a double negative. I know that a double negative is the same thing as a positive. Now I can go in and identify. I can say, okay, well, here x matches with x. This minus matches with the first minus. And then now I can see that h matches with -2. All right, so there's my vertex. My x coordinate is -2. And then k here, you can see, is -5. So my vertex is -2, -5. So again, since this graph is concave down, that would be the maximum point on the graph. Whoops. That would be the maximum point on the graph. All right, so now that we've had some practice identifying the vertex, let's go ahead and do an entire problem. All right, so this problem is going to have 4 parts, parts A through D. It starts off and it says, consider the following function, q of x equals x minus 1 squared minus 9. It says find the vertex for part A. All right, so just right off the bat, the first thing I'm noticing is that my value for A here is 1. And since A is positive, I know that my graph is going to be concave up. So just get that out of the way and kind of have an idea of what my graph looks like. Now I can go ahead and identify the vertex. Just writing vertex form up underneath here. Okay, so now I can see that H matches up with 1, K matches up with -9. So my vertex, which I know is the ordered pair HK, is 1, -9. So that's my vertex. All right, part B says to find the x-intercepts, if any. So it is possible that your quadratic function could have no x-intercepts. That's totally fine. Doesn't mean you did anything wrong. So just FYI, this is what it would look like if you had a quadratic function with no x-intercepts. All right, so that would just mean that the quadratic for the entire parabola lies above the x-axis, so it does not cross the x-axis anywhere, and therefore there are no x-intercepts. So that's totally fine if that happens, if you end up with no x-intercepts. But let's see if we can find any here. Remember, the process for finding the x-intercept is that you replace y, I'm going to put y in quotations here, replace y with 0 and solve for x. Now I'm putting y in quotations here because I'm dealing with function notation, but I know that q of x or f of x is the same thing as y. So I'm going to replace q of x with 0, and then I'm going to solve for y, or excuse me, solve for x, get x by itself. So I have 0 equals x minus 1 squared minus 9. I'm going to use the square root method to solve this. So I'm using the square root method. Right, so the square root method tells me that I need to move the constant over to the other side. All right, so I end up with 9 equals x minus 1 squared All right, the square root method tells me that I can take the square root of both sides to get rid of that squared. So I'm going to take the square root of both sides. I'm going to make sure that on the number side that I do the plus and minus square root. All right, so on the right-hand side, the squared cancels with the square root. On the left, the square root of 9 is 3, so that's plus or minus 3 equals x minus 1. Now I'm just going to go ahead, I'm trying to solve for x, so I'm just going to move that 1 over. So 1's cancel. Right now I have 1 plus or minus 3 equals x. Let's go ahead and split that up. We have x equals 1 plus 3, x equals 1 minus 3. So that's 4 and negative 2. All right, so let's write our x-intercepts as ordered pairs. All right, so our first x-intercept would be the ordered pair 4, 0. Remember, we replaced y with 0. That's why y is 0 here. And then negative 2, 0. That's my two x-intercepts. Excuse me. All right, so that was part B. Let's see what we're doing next. Next, it says find 2 points on the graph of the parabola other than the vertex and the x-intercepts. So just to remind you what those points were, we had 1, negative 9, and then what? 4, 0, negative 2, 0. Okay. We're going to do this on our calculator just to save us a little bit of work. So I'm going to pull up my document camera. Okay. All right. Clear everything out. It's nice to start with a blank screen. All right, so I'm going to use the little table function up here on my calculator to save me some work. And in order for me to use the table function, I need to put my function in the y equals screen. So clear whatever you got in there, make sure you clear it out. Type your function in from over here. All right, so we have parentheses, x, oh, sorry, the x button is right here by the alpha button. You can see there's x. All right, so x minus 1, parentheses, squared, minus 9. So I'm going to go ahead and make my table. So I'm going to go to second graph. That's going to make my table. Second graph. All right, so you can see it's already got my table populated. If you get to this point and you have a blank table, you can adjust those settings right here where it says table set. You would just go to second window and adjust your table settings. All right, but all I need to do here is I just need to pick 2 of these points. You can pick any 2 that you want. I'm going to try to pick some easy ones here. We'll pick 0, negative 8. Let's write this down. 0, negative 8. And then we'll pick 2. We've already got this one. This is the vertex, 1, negative 9. So we'll pick 2, negative 8. So that's 2 points other than the vertex and the x-intercepts. You can pick any 2 points you want. It does not matter. All right, so now we have a total of 5 points. We got the vertex, we got the x-intercepts, and we got 2 other points. So now we're ready to graph our parabola. So let's go down here and graph our parabola. Let me write out all the points we're about to graph. There we go. That looks a little better. So here's our points that we have. 1, negative 9, 4, 0, negative 2, 0, Then we had 0, -8, and 2, -8. All right, so go ahead and plot those. 1, -9, so I'm going to the right one, down 9. I know that this is a 10 by 10, so I know that's 10, so this has to be -9. 4, 0, 1, 2, 3, 4. -2 zeros. 1, 2, 0, -8. So stay on the origin, but go down 8. All right, and then 2, 8. So over 2, down 8. All right, now we're ready to draw our curve. Just do the best you can. It doesn't have to be perfect. Mine's probably going to look really janky. There we go. My right-hand side of my parabola. Being super careful. There we go. Left-hand side of my parabola. Something really cool about parabolas is that they have, they're symmetric. They're symmetric across this line in the middle. Let's see if I can draw it here. So it's the vertical line that runs through the vertex. And this line has a special name. It's called the axis of symmetry. So you can see it's perfectly symmetric across that line. So you go over one, you hit a point. You go to the right one, you hit a point. Here, if you go to the left, 1, 2, 3, you hit a point. You go to the right, 1, 2, 3, you hit a point. So they're perfectly symmetric, which is nice, which means that you can just draw, you know, one side of the parabola, reflect those points over, and you got the other side of the parabola. Can save you some time. All right. Let's talk about what happens when you have a function that's in standard form and you need to find the vertex. We'll come back to that other one. All right, so let's talk about what happens when you have a quadratic function that's in standard form and you need to find the vertex. All right, so remember what standard form looks like. So this is standard form, ax squared plus bx plus c. All right, so if you're in standard form and you need to find the vertex, this is how you'll do it. We know that the vertex is going to have two parts, right? It's going to have an x coordinate. Try that again. X coordinate. And it's going to have a y coordinate. So to find the x coordinate, it's just going to be -b over 2a. So a and b come from standard form there. So b is the coefficient on x, a is the coefficient on x squared. That's the x coordinate of the vertex, -b over 2a. The y coordinate of the vertex can be found by plugging in. So just plug in the x coordinate. Well, let's say it this way. Plug x coordinate into your function. So to find the y coordinate, all you got to do is plug that x coordinate that you just found into your function. Now, the formal way of writing the vertex looks like this. Whoops. Use a different color. So this is the formal way to write the vertex when you are in standard form. But I think this is a little bit easier to understand. So this just says the x coordinate is -b over 2a. Y coordinate, you just take -b over 2a, plug that into the function. Whatever you get out is the y coordinate. All right, so we'll practice that in just a minute. Actually, we'll go ahead and do the example. Then we'll come back to that one with the graph. Okay, so it says the total revenue for Fred's Estates LLC is given as this function here, r of x equals 200x minus 0.25x squared. That's our revenue function. It says where x is the number of villas booked. What number of villas booked produces the maximum revenue? All right, so first of all, I can tell by looking at this that this is not in descending order. So let's write that revenue function in descending order. So that's negative 0.25x squared plus 200x. Now I can see by looking at this that this is a quadratic function. I can see that my value for a is negative, so this is going to be concave down. And notice that the maximum point is going to be up here at the vertex. So they're asking for the maximum here, so I'm going to have to find the vertex. So we're going to need to find the vertex. But let's look and see if we need the whole vertex or what we need. So it just wants to know what number of villas booked produces the maximum revenue. X is the number of villas booked. So we only need to find the x coordinate of the vertex. Now I'm going to show you how to find the x and the y coordinate just so you can see an example. But for the problem, they're only asking us to find the x coordinate of the vertex. All right, so we know that the x coordinate is defined as negative b over 2a. So here, negative 0.25, that's a. B is 200. So it's going to be negative 200, because it's negative b, over 2 times negative 0.25. Let me show you how I'm going to plug that into my calculator. Okay. So to get out of this screen, I'm just going to hit second quit. So second mode takes you to quit. All right, so here's how I'm plugging this in. Negative 200, make sure you're using the negative, not the minus, divided by, now I need to put the entire denominator in parentheses so that my calculator knows that everything that's inside these parentheses is in the denominator. So that's 2 times negative 0.25, close parentheses. So that's 400. And that's really, whoa, that's really all they were asking for, right? They just wanted to know what's the number of villas booked that produces the maximum revenue. Told us that X is the number of villas booked. So this would be the answer, 400 villas. But let me just show you how you would find the y coordinate. So to find the y coordinate of the vertex, you would just take the number you found here for the x coordinate and then plug it into your function. So that's going to be r of 400 equals negative 0.25 times 400 squared plus 200 times 400. All right, so let's plug that in. Negative 0.25 times 400 squared plus 200 times 400. Whoops. All right, so 40,000 is the maximum revenue. That's not what they were asking for. I almost circled the answer. I mean, I almost circled it as if it was the answer, but they didn't ask us for what was the maximum revenue. They just said what number of villas booked produces the maximum revenue. So this would be the actual maximum revenue. And again, I just wanted to show you that so you've seen an example of finding the vertex when you're in standard form. All right, and then the last thing that I wanted to show you was this little example here. It says, find a formula for the quadratic function depicted in the following graph. And it gives you this little graph. Notice that we don't exactly know what the vertex is. It's not lying perfectly on a point that we can easily identify. But some numbers that we can identify, look right here, we have some x-intercepts we can identify. Then it also looks like it's perfectly going through some points right here. So we can identify those 4 points. So let's see, that would be -2, 0. This would be -6, 0. And then this is the point 0, 6. This would be -7, 6. Okay. All right, so there's 2 ways that you can find the formula for a quadratic function when it's depicted in a graph. The first method uses the vertex. So if you know exactly the coordinate, if you know the coordinate exactly for what the vertex is, here you can see we don't know exactly what it is. We could only guesstimate. So we're not going to use that method. But there is another method we can use that involves the x-intercepts. All right, so that's the method we'll use. We just need to remember -2 and -6 were our x-intercepts. -2 and -6. Okay, so this is a little template for you to follow whenever you do this on your own. So if you're using the process or the method of using the x-intercepts, then you want to start off with this little template. It says that your quadratic function can be written as f of x equals a times, and then you're going to have these 2 little binomials. You can see I'm leaving blanks right here. Whoops, let me write that one again. We have x minus. Okay, you can see I have 2 little blanks right here, and right here. And those little blanks, those little blank spots are going to get filled in with whatever your x-intercepts are. So we'll say fill in x-intercepts here. Okay, and then a is just some coefficient that we do not know it yet. We're going to have to find it. All right, so let's see. We have f of x equals a, we don't know, times x minus, filling in the first blank with one of my x-intercepts, we'll use -2. You could put -6 first, it does not matter. And then my second one, we have x minus, fill in the second blank with -6. Okay, go ahead and switch your double negatives to positives where you can. In this case, it's in both of them. So plus, plus. Now what I need to do is I need to plug in a point from the graph for the coordinate pair x, y. Here, y is being replaced by f of x, so if it makes you more comfortable, you could just write f of x here. We know that f of x is the same thing as y. All right, so let's go to the graph. We're going to try to find an easy point to plug in. So find one with easy numbers. All right, we identified a couple of points up here that it went through. This one definitely looks like it would be more easy to plug in. So let's plug in the point 0, 6. So we have 0, 6. So this is going to be our x. This is going to be our f of x. All right, so we have f of x is getting replaced with 6 equals, we don't know what a is. That's what we're trying to figure out. We're replacing x with 0. So 0 plus 2 times 0 plus 6. Did I do something wrong? Oh, did y'all see that whenever I did that the first time? I didn't even notice that I identified that point wrong. Let's fix that really quick. Look, I identified, oops, that one could be negative 2, 0, but that was actually negative 1, 0, wasn't it? That was supposed to be negative 1, 0. So this is the origin, so that would be negative 1. That was my bad. Sorry, guys. Gotta fix that. Goodness gracious. All right, so I gotta fix it here, and then here, and here. Good night. Sorry. So that was actually negative 1 instead of negative 2. All right, so now I fixed that. Again, sorry about that, you guys. So we have 6 equals a times 0 plus 1 is 1. 0 plus 6 is 6. 6 times 1 is 6, so that would be 6 equals 6a. Divide both sides by 6. You get a equals 1. All right, so now all you got to do is go back up here. Whoa, kind of overshot that. All right, so go right there, plug in the value for a, so that's f of x equals 1 times x plus 1 times x plus 6. And then you're done. We really don't even need to write that 1, right? Because it's understood to be there. So you don't have to write the 1. But that's it, you're done. Okay. So that's everything for section 3.3. If you have any questions about quadratic functions, please let me know. Otherwise, I'll talk to you guys soon.